I'm pleased to introduce Dr. Ming Huang, who will be sharing his presentation, Improvements on Methodology for Tier 1 Toxicity Testing on Non-Target Beneficial Insects. Dr. Huang received his PhD in entomology from the University of Arizona and has more than 17 years of research experience, focusing on the agrochemical industry since 2014. Dr. Huang currently serves as the research team leader at the EAS laboratory in Prospect Hill, North Carolina, where he focuses on entomological and specialty products testing. Dr. Huang, thank you so much for joining us.
Well, thank you, Nicole, for the intro and giving me this opportunity to present.
Absolutely. Let me share the presentation here.
All right, so today I'll be telling you a little bit about how to improve the methods for Tier 1 toxicity testing on beneficial insects. So one of the types of beneficial insect studies is the OPPTS 8854340. And this test mainly focuses on microbial oral feeding. And for this test, they required 3 species covering at least 2 different ecological categories. The two ecological categories that are most commonly used for these tests are the predaceous coleopterans or predaceous beetles and the predaceous neuropterans or predaceous lacewings. For this test, like I said, it mainly focuses on oral feeding via the introduction of the test item in the diet. And for this test, it's very important that you are able to measure diet consumption. Also, the test duration is important for these tests, and they could go up to a maximum of 30 days, depending on when the control mortality reaches greater than or equal to 20%. And for these tests, a negative control is often required. A negative control is definitely required. There's the untreated control, and then a blank control is often required when your test item has live microbes and you will want to include a blank formulation. A positive control is not necessarily necessary, but it is sometimes requested by sponsors. And the second type of test for beneficial insects is the 8804350. And for this one, it tests biochemicals and mainly focuses on contact toxicity. And for this type of tests, you typically include 3 species in any of the listed categories here. But the 3 most common categories are the predaceous coleopterans, or the predaceous beetles, the predaceous neuropterans, or the predaceous lacewings, or the parasitic hymenopterans, or the parasitic wasps. And for these type of tests, the test item is introduced via application on a substrate surface, usually on foliage or leaves. And the insect comes into contact with the substrate that is applied. The test duration, unlike the other tests, is a lot shorter. So they have a maximum of 72 hours of observations instead of up to 30 days. And again, the termination is dependent upon the control mortality. As soon as it reaches greater than or equal to 20%, you stop. For these tests, a negative control or untreated control is absolutely required. And a blank control, again, is included if your test item has live microbes. And for these tests, unlike the previous tests, a positive control is often included. And for both tests, you really need a good climatic chamber to run these. And for us at Eurofins, we have very large walk-in chambers that can accommodate many studies at one time. And within these chambers, you have heating cooling units that maintain the desired temperature that you want. And also, in addition to temperature control, You also have humidity control units in there that controls the level of humidity that you want. Also included sometimes is a light-dark cycle timer that allows you to turn the lights on and off at different to accommodate for different photo periods. And in addition to all of those things, you often have a fan that will create proper air circulation within the chamber. And finally, for especially for GLP studies, it's very important to include a data logger unit that's able to capture the environmental conditions during testing. And for the microbial oral toxicity tests, here I show visually some of the organisms that are suitable for these tests. On the far left, you see the green lacewings, and those will fulfill again the predaceous neuropteran ecological category. And lacewings are available year round, and we can conduct tests with them throughout the year. In the middle, you see rove beetles and mealybug destroyer beetles, and these are also lab reared and available year round. The one caveat with the rove beetles, however, is that so far they tend to only give you a duration of about 6 to 8 days of test duration, whereas the other organisms may give you a much longer test duration. On the far right, you have the convergent lady beetles and the spotted lady beetles. These two beetles will fulfill the predaceous coleopteran ecological category. The convergent lady beetles on the top right are only available between June and September because they are field collected and are seasonal. The spotted lady beetles on the lower right hand side, they are lab reared and field collected. But if you choose to do tests with the field collected spotted lady beetles, they will be only available between May and June. Whereas if you, but it's a lot cheaper to conduct a test. But if you want to do a test on spotted lady beetles anytime outside of May and June, they can lab rear them, but it's much more expensive. So for these microbial oral toxicity tests, there are several key things to consider. One is which of these insects are large enough to allow for good assessments and measurements of consumption. Second, what insects are available seasonally and what insects are available year round. Third, which species can survive the longest in the lab to give you as close to the 30-day test duration as you can. Fourth, what is the most suitable diet type to feed each of these different species in order to have maximum survival in the lab? And lastly, what is the best test setup to deliver the test item to the test organisms? Here I show one example of the testing setup for the green lacewings for microbial oral toxicity testing. And here you see that we offer these lacewings a solid diet paste, usually in the open trough. And in addition to the solid diet paste, it's very important to also offer the lacewings water. The water will give them an extra source of liquid to survive. And both of these are inserted in a very simple test container that is made out of a 12 or 16 ounce disposable plastic deli container. And the screen lid, the lid has been modified to include a screen that will allow maximum airflow. And down at the bottom, you can see in the test unit sometimes a piece of harborage, like a piece of paper, is also included in the test unit to provide the lacewings with harborage and something to land on. And for very important to measure consumption accurately, we not only include test units with lacewings and a diet, but we also include test units that don't have lacewings and just the diet. And for those second type of test units, they're to measure the evaporation of the food so that they can be accounted for to give you the most accurate measure of consumption. And we also have a 3 decimal place scale that's able to measure the small amounts of food that's consumed. In this second setup for microbial oil toxicity testing, I'm showing an example of a test unit for rove beetle testing. And for this, again, it's a very simple 12 to 16 ounce plastic disposable deli container. On the lid, again, is a screen that is modified into the lid to allow for good air circulation. And the hole also is on the lid for loading up the beetles into the test units. And on the very bottom in black shaded area is showing a filter paper that offers the beetles some harborage, as well as it can be moistened to give the beetles good humidity and moisture. In addition to the moistened filter paper, there's also 2 dental wicks that we moisten to give some extra moisture to the beetles. And as you can probably tell, for these rove beetle tests, it's very, very important to have a very humid environment to maximize survival. And the diet that we offer these beetles is a what we call a bee slurry diet, but really you can use any insects you want. And we basically blend up the insects and um, mix it with a little bit of water and offer this slurry to the beetles, which they feed on. And this insect slurry diet is offered to the beetles in the open trough as well. And lastly, here I show for microbial oral testing a setup for lady beetles and mealybug destroyer beetles. But this setup can really be used for any beetles that feed on sugar water diet instead of solid food. And once again, the test unit setup is very simple. The test unit is made of a 12 to 16 ounce deli container, and the lid is modified with a screen to offer maximum air circulation. And the diet, which is sugar water, is mixed and then placed into a feeding tube. And the feeding tube is inserted through the top of the lid. And as you can see in the feeder, there's a little hole at the bottom of it to give access to the beetles to feed on. And in addition to the food, we also offer on the very bottom sometimes a piece of paper to give the beetles harborage and something to hold on to. Okay, and so now that we finished talking about the microbial oral testing, we can move on to the bioinsecticide testing, what we call translational studies. And for these studies, here I show the group of organisms that are most suitable for these tests. On the far left, you have again the green lacewings, and they are available year-round and can be conducted throughout the year. And on the very bottom, now in addition to all the beetles and lacewings, because these tests are much shorter than the microbial oral testing, and consumption is not needed to be measured, you can now offer parasitic wasps as well. And on the very bottom is one example of a species that we use, but really there are many species of parasitic wasps that are suitable for these tests. And the wasps are generally lab reared, and so they're available year round for testing. And in the middle, you see the spotted lady beetle. Um, and once again, these guys are available um, as field collected organisms from May to June and is less expensive. But you can also do these tests on the spotted lady beetles throughout the year from lab reared beetles, but those will be much more expensive. And then on the bottom of that are the rove beetles, which are lab reared and available year round. Um, and they do have a shorter duration of survival in the lab. But for these tests, it's not as critical because the tests only go for maximum of 3 days. On the far right, you see the convergent lady beetles. And these beetles are field collected, so they will only be available from June to around September. Um, and then on the very bottom right are the mealybug destroyer beetles, which are lab reared and they can be available for testing year round. And for these bioinsecticide translational studies, there are several key considerations as well. One is which insects are big enough to allow for good assessments of mortality. So you should be able to see them. Second, what insects are available seasonally and which insects are available year-round for testing. Third, what species can survive at least 72 hours or 3 days under lab conditions, which is a lot less restricted than the oral microbial oral toxicity tests that have to go for a maximum of 30 days. Uh, Fourth, you also want to know what is the most suitable plant to use for application because different plants will have different leaf sizes, different leaf shape, and also surface texture. And lastly, you have to know what is the best test unit setup to use to make sure that the test organisms will contact the treated surfaces. And for these tests, it's very, very important to have a good, reliable track sprayer in the chamber system. And for us here at Eurofins, we have one of the best track sprayers and spray chambers for these tests. And here you see a diagram of an example of a track sprayer. And for these, it is large enough that you could put a whole plant into the chamber and you can adjust the height of the spray platform to accommodate for plants of different sizes. Second, these spray chambers are very safe to use because they are completely enclosed. And so when you do your spray application, there'll be no test item that will escape from the chamber, as well as there's usually a built-in fume hood in these chambers that help evacuate any extra test item that is not applied to the surfaces. And also, our track sprayers are very efficient and can provide a very precise application. There are many adjustments that you can make to the track sprayer, such as the speed of the sprayer, the output of the sprayer. So that will allow you flexibility in many different types of settings. And for these bioinsecticide translational studies, no matter which organism you use, they have a generally similar setup. And the test units used for these tests are once again, a 12 to 16 ounce disposable deli container, and the lid is modified with a screen to allow for maximum airflow. And since these organisms do not have to survive in the test units for longer than 3 days, you can really just offer them sugar water as a food source, and they do fine. But the most important thing in this test unit is that after we detach the leaves from the plant that has the test item applied to it, we are able to stick these detached leaves to the walls in a horizontal position in the test unit to sort of mimic a natural position of a leaf, and also to provide the test organisms with exposure both on the top surface and the bottom surface of the leaf. And so that really ensures that the test organisms can come into contact with the test item. And so those are different methods, improvements to the methods for beneficial insect testing. If you have any questions about any of the slides or any of the topics that are covered in this presentation, feel free to contact me in the email on the slide, and I'll be happy to address any questions.